that was beautiful. Multi-step linear equation. All right. We're gonna look at these YouTube videos this week. What happened? All right. So we talked about one step and two step. I really am just gonna focus on reviewing multi-step, except for two things. And these two things are technically examples of one-step linear equation. The first one is something like this. If I had 3 halves x equals 12, I have a fraction all of a sudden. How do I isolate x here? What's in the way of x right now?
The fraction.
Yeah, 3 halves. So how can I get rid of it? Okay. So there's a lot of ways we could think about it, right? I heard we could put a 1 on the bottom, maybe something like this. That might help us to see a way of getting rid of the 3 halves. Didn't actually get rid of it really, but we could then think about this as being a multiplication. How can I get x alone? What would I do if I had 1 half of x? If I just had 1 half of x equals some number. There were some problems like this last time on your homework, right? Yeah, what would you do?
You basically would just multiply it by 2.
Yeah. I actually really like the way that you said that. We'd multiply it times 2 over 1. Yeah, and then we have 2 over 2, which kind of cancels out. So how do you think I could get rid of 3 halves? Yeah. Exactly. I multiply it times 2/3. And I have to multiply both sides of my equation times 2/3. Because then I can cross cancel. 2 cancels with 2, and 3 cancels with 3. What is this called? 2/3 is the what of 3 halves? Do you guys know the term for that? Starts with an R. I actually don't know if I spelled that right, but the reciprocal. Right? 2/3 is the reciprocal of 3 halves. It's the reverse. It's the flipped over version. It's the upside down fraction. Right? So if you ever have a fraction in front of x, to get rid of it, you just multiply times the reciprocal. And then 12 times 2/3. Here I would also upstairs, downstairs cancel. And then I would multiply 4 times 2. And my final answer would be 8. So another one of those. What if I had something like 4/5 x equals 7? So what do I do if I have a fraction? I multiply times the reciprocal. What is the reciprocal of 4/5? 5/4. So I multiply both sides of my equation times 5/4. That's going to cancel here, and probably you're going to want to write 7 over 1 to help you remember multiply the top and multiply the bottom. So I have x equals, is there any canceling I can do from the top to the bottom? No. So I'd have 7 times 5, which is 35/4. Can x be a fraction? Is that possible? Yeah. A fraction's a number, right? X can be really anything. And I can't reduce that fraction, so I just write it just like that. This is an improper fraction, which in algebra we like, right? We would rather have an improper fraction than a mixed number. So we're going to leave it as 35/4. We're not going to try to divide 35 by 4. Okay, 35 divided by 4 is 8, and then the remainder of 3. So it'll be 8 3/4, or 8.75. These are all different ways of writing the same number. But in algebra, we like this version the best. Right? This is the version that we prefer. Sometimes people like decimals, but I'm not a big decimal fan. I love improper fractions. And then the other thing I want to talk about is this. What if I have negative x equals 17? How do I isolate x in this example?
X is 1.
We could think about a 1 in front of x, right? Or a negative 1. We could add that in. So then how could I get x all over? What's in the way is this negative 1, right? So divide by not necessarily 1, but negative 1. And then this cancels and we have x equals, what is 17 divided by negative 1?
Negative 17.
Negative 17. Because a positive divided by a negative is a negative. And 17 divided by 1 is just 17. So what if I had negative x equals negative 6? What am I going to do there?
Divide by the negative.
Divide by negative 1. This cancels, so we have x equals negative 6 divided by negative 1. A negative divided by a negative is a positive 6. Just 6. You see why it's not negative anymore? Because we have a negative divided by a negative. So this negative and this negative, they cancel each other out. When we're multiplying and dividing, negatives cancel other negatives. Okay, so let's look at some longer multi-step problems. Still going? Yeah. All right. So first I want to look at something like this. 8x plus 6 equals 4. So this is really not that much more than a two-step problem. But the thing about this problem is that we have x's on both sides of our equation, right? And so we talked about yesterday what we do when we have x's on both sides, which is we always subtract the smaller number of x's. So which x's would I subtract? Yeah, which one would I want to subtract? I would subtract to 6, right? Because that's a smaller number. And if I subtract it from one side of the equation, I have to subtract it from the other side of the equation. Anything I do to one side, I do to the other side. Now, because I've nicely written it below, it's easy to combine our like terms, right? 8x minus 6x is 2x plus 6 equals 4 plus 0, because 6x minus 6x is 0. So I'm not going to write plus 0 because 4 plus 0 is just 4. Now what do I do? Minus 6, right? This should be really familiar. Get rid of that. 2x equals negative 2. Divide by 2 so that that cancels. X equals negative 1. So we always want to subtract the smaller number of x's. When we have x's on both sides, subtract the smaller number of x's. But sometimes it's not obvious. Like we saw a couple of examples of this yesterday where the smaller number of x's might not be so obvious. What's the smaller number of x's in that problem? Is negative 5 smaller?
No.
Yeah, which one is smaller? Now, what do I mean by smaller? It's part of the question. I just mean the lower number. So which number is lower, negative 5 or negative 10? Negative 10 is way lower, right? If we pictured our number line, if this is 0, we'd be at negative 1, 2, 3, 4. Negative 5 is right here. Negative 10 is another 5 over, right? This would be negative 10. So this number is smaller. It's a lower number. And what do I mean by subtract? Well, I don't really want to subtract anything here. How am I going to get rid of negative 10x? Yeah, I add 10x. So technically, I am technically still following this rule, because negative 10 is smaller than negative 5, and plus 10 is actually the same thing as minus negative 10.
Add 10.
So then I have to add 10 over here. So negative 5 plus 10 is what? So think about, if we start at negative 5, we're going to add 10. We're going to go in that direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Are we in the positive numbers or the negative numbers?
Just 5.
Yeah. It's a positive 5x. This cancels. That's the whole reason that we did this. Okay, what's our next step?
Subtract 7.
Subtract 7.
Which is 22.
Nice. Is it a
Negative
positive
22.
22? Nice. It's a negative 22. And what's my last step?
Divide the 5 after that.
Divide x equals negative
22.
Okay. And that's your answer, right? It's a fraction. There's no way of reducing that fraction because there's nothing that goes into both 5 and 22. No number goes into 5 that also goes into 22. Except 1, but that doesn't help us, right? So we always get rid of the smaller number of x's first when we have x's on both sides. How about this? If I had something like this. What's wrong with this problem? I can't tell which side has the smaller number of x's at all. Right? Because there's like x's here and here and here and here and here and here. So what do I need to do first? Yeah, we've got to combine our like terms before we try to get rid of those x's. So on this side of the equation, the like terms are 3x, 2x, and 1x. Right. Yeah, you're one step ahead of me. That is 6x. And then what do we have left? Plus 5 and minus 3, which is
Plus 2.
plus 2. On the other side, we've got x and 2x,
4x.
which makes 4x. And then we've got 5 minus 7 plus 10 plus 2. Wow, yeah. 5 minus 7 is negative 2 plus 10 plus 2. So negative 2 plus 10 is 8, and then we have plus 2 again. Oh, now it's pretty clear which side has the lower number of x's, right? We would get rid of the 6x, right?
Yeah.
4x. Wait, which one?
No, the 6x.
Which one should we get rid of?
The 4x.
4x, 6x.
Bigger.
How do we decide?
It's lower.
Which one's lower?
4x.
4x is lower. Let's get rid of that. Does it matter? The real answer is no. It doesn't actually matter. You can get rid of whichever x you want to get rid of. But if we subtracted 6x, we would end up with a negative number of x's. So we're going to have fewer negative numbers. Okay, 2x plus 2 equals 10. Ah, these start to look really familiar when we get here, right? Some number of x's plus some number equals some number. Subtract 2. 2x equals 8. I already heard it. X equals 4. And then I'm done. Right, and then I'm done. Okay. One last thing. One last thing that we should add in. Let's do that. Okay. What type of problem is this, or what property do we have to use to solve this type of problem? The distributive property, right? So I have to distribute the 2, right? So I have 3 minus, what's 2 times x? 2x. So I heard plus 10. I would disagree with that.
It's minus 10. No, you're right.
There is a plus here.
Yeah.
But what am I actually multiplying? Remember that when I multiply this number, I have to multiply the negative along with that number, right? So not just 2 times 10, 2 times 5, negative 2 times 5. So that negative travels with the 2, and it affects everything in those parentheses. Okay, now what can I do?
No, you do plus 2x and the 7x.
What would I do with them? Yeah, so I could do that next. I could plus 2x on both sides. Then what would I have left over on this side? 3 minus 10 equals 9x. What's 3 minus 10?
Add 10.
We could add 10 to both sides, but it's easier to combine like terms. If we added 10 to both sides, watch what we end up doing. 3x, so 3 minus 10 equals 9x. Now I've got 3 equals 9x plus 10. What do I want to do next?
Oh.
Subtract 10. Wait a second.
No,
That was up here, right? Now, that's not to say that this is wrong. You totally could do it that way. It's just kind of adding extra steps. So instead, I would combine my like terms. 3 minus 10 is negative 7 equals 9x. What's in the way of that x? Divide both sides by 9. So x equals, I'm flipping it around, negative 7 divided by 9. It's a fraction, right? There's nothing else I can do with that. 7 doesn't get divided by 9. Unless we want a really long decimal.
No, thank you.
So I'm just going to leave it like that.
Thank you very much.
Yeah.
Are all answers fractions?
No. Well, I mean, sort of, I guess. Any number is a fraction. But we saw lots of answers that were integers, right? What was the last problem before this was x equals 2, right? Or 4, that's right. So sometimes they'll be fractions, but sometimes they won't. Can I erase this?
Yeah.
So I want to talk about the order that I would do these steps in. Right? The order that I would do the steps in. Let's say I have something like this. 5 minus 3 times x plus 2 plus 2x plus 7 equals x minus 48. Yeah. Okay, the first thing that I always do, step 1, is to use the distributive property. Just like PEMDAS starts with parentheses, I want to start by getting rid of my parentheses. And the best way to do that is to use the distributive property. So something like 5 minus 3x minus 6. Because remember that the negative distributes with the number.
Wait.
Plus 2x plus 7 equals x minus. Did I do something wrong?
Yeah. No.
Step 2. Step 2, I like to next combine like terms. Because it's really hard to, I could start moving things over. I could be like, oh, I want to move this negative 3x over here. And I want to move the positive x over here. And I want to move the negative 6 over there. And I could like, oh, I'm going to add 6 to both sides and add 3x. And then I'm going to add 6 over here and plus 3x. Oh, and then I need to subtract 2x. Okay, I'll write that down. Oh, and then I better subtract 7. And okay, and then subtract. And now I've just got so many things that I'm trying to do. I'm probably going to make a mistake doing it this way. So it's simpler if we first look on both sides. So remember, we're not going to combine anything on this side of the equation with anything over there yet. We're just going to look on one side of the equation and combine all the like terms. So for example, over here I have minus 3x and plus 2x. And then I have a 5. So I'll write plus 5 because it's positive, minus 6, and plus 7. What is negative 3x plus 2x?
No, x, negative x.
Negative 1x or negative x. 5 minus 6 plus 7.
Negative 1 plus 7.
Negative 1 plus 7 is 6. Beautiful. Are there any like terms to combine on this side?
No.
No. So I don't need to. X minus 48. So I've combined all my like terms. Next, step 3. Move all x's to one side. Move all the x's to one side. So in this case, which x would I want to move? Would I move the negative x or the x?
No,
Could.
either one.
Doesn't really matter, but if we do it this way, you'll see why I told you not to do it this way. Because we end up with What is negative x minus x? It's negative 1 minus 1.
It's negative 2x.
It's negative 2x. Which is totally fine. That's totally fine. But it is negative. If we had moved it the other way, we would have had a positive number, right?
But that works.
But it doesn't matter. I'm not going to redo it. I'm just going to say, oh, if I had moved the negative, I would have ended up with a positive. And then step 4 is isolate x. So how could I isolate x in this problem? Subtract 6 from both sides. So negative 2x equals, let's see, negative 48 and negative 6. So they're both negative, they combine.
Wait, no. A negative.
So what's 48 plus 6? 54. And it is negative, right? I would really recommend, especially for the quiz, that you have a calculator near to just check your answers on stuff like this, right? Because I would hate for you to get this whole problem wrong because of making a mistake adding negative numbers. It's important to know how to do this, and whenever you're allowed to use a calculator, you can do this in a calculator. Okay? So we're going to divide both sides by negative 2, right? What's a negative divided by a negative always going to be? Always going to be a positive. And then 54 divided by 2 is 27. Yeah, so don't get stuck up on these negatives, right? Remember your rules, know what you're looking for, and check your work with a calculator. Because it will help if you type in negative 54 divided by negative 2. Now remember, on a calculator, like one of these, yeah, you cannot type in negative 54. You have to type in 54, make it negative. I don't know if this is showing up to you on here, but right, to get negative 54. Divided by, and I'm not going to type in negative 2, I'm going to type in divided by 2 negative. Boom. And then it shows up as negative 2 equals 27. Right? If you have a scientific calculator, then you probably can type the negative first. But a lot of you have this type. And these are the type that we have in class. So. Alright. Beautiful. That's what I wanted to record today.